Hello, my students in grade 6. I hope you are all fine. This is a new mathematics session. It is lecture 1 in semester 2. And as you can see, the title of our lesson is Triangles 2. This is part 2 of our lesson that we started in semester 2, the triangles. Objectives of this lesson. Objective number 1, I wanted to remind you of this very important sentence that will be used in our session. The sum of angles in a triangle is 180 degrees. Objective number 2, we will find the measure of a missing angle in a triangle. Number 3, define and draw special lines in a triangle, the height, the median, the bisector, and perpendicular bisector. So please always remember the following sentence. The sum of angles in a triangle is 180 degrees. Again, what do I mean by this sentence? Suppose we have a triangle ABC. In this triangle, we know that we have 3 angles. An angle at vertex A, we call it BAC, and it has a measure. An angle on vertex B, we call it ABC, and it has a measure. An angle on vertex C, we call it ACB, also it has a measure. So if I wanted to apply this sentence, I say angle BAC plus the measure of angle ABC plus the measure of angle ACB is 180 degrees. So the sum of angles in a triangle is always 180 degrees. Now we will apply through exercises. Calculate the measure of a missing angle in a triangle. What do I mean by missing angle? I will be having a triangle. I will know the measure of 2 of its angles. I will have a missing measure, a measure that I don't know it. I should find it. As you can see here, we have a triangle ABC. Here, the angle at vertex A is BAC. It is measure A. A means I don't know its measure, so I should find the measure of angle BAC because the measure of angle ABC is given 70 degrees and the measure of angle ACB is given 50 degrees. Always, whenever we have a missing measure of an angle, we should always depend on this information to calculate the measure of a missing angle in a triangle. The information is the sum of angles in a triangle is 180 degrees. So again, I will say, what is the angle of vertex A? It is BAC, because if I wanted to name the angle at vertex A should be in the middle of the name of the angle. It is again BAC. What do we call the angle at vertex B? It is ABC. The angle at vertex C is ACB. So these are the 3 angles that I have in this triangle. Now, how do I apply this sentence? The sum of angles in a triangle is 180 degrees. I should add angle BAC plus angle ABC plus angle ACB means equal 180 degrees. So I simply add the first angle with the second angle with the third angle, because sum means addition. I am adding, means equal 180 degrees. How did I get this sentence? It is the sum of angles in a triangle. Now, after writing this sentence, I ask myself, Do I know the measure of angle BAC? I look at angle BAC. Do we know the measure of it? Do we have its measure in numbers? No. So this is the missing angle. I leave it as it is, BAC. Plus ABC, its measure is 70 degrees. So ABC, the name, I replace it by the measure 70 degrees. So I replace angle ABC by its measure, which is 70 degrees. Plus the measure of angle ACB is 50 degrees. So I replace the angle ACB by 50 degrees equal 180 degrees. So here in the second step, I replace the given angles, and the missing angle, I leave it as it is. Now 70 degrees plus 50 degrees is 120 degrees. So I leave angle BAC plus 120 degrees is equal to 180 degrees. Now I still have angle BAC, which is missing. So angle BAC is equal 180 degrees, and I take the plus 120 to the other side, it becomes minus 120 degrees. Now I can calculate angle BAC is equal to 60 degrees. I write here inside this angle is equal to 60 degrees. Please, these steps should always be written and should always be followed. If you solve without writing these steps, your solution will be missing. So please always follow the same procedure to find the measure of the missing angle in a triangle. I will give you other examples. Given triangle ABC, so we have triangle ABC, we should find the measure of angle ACB. So we can see that in this triangle, I have the measure of angle BAC 120 degrees. The measure of angle ABC is 34 degrees. I have a missing angle at vertex C, which is ACB. Also here, we should start from the sentence, which is the sum of angles in a triangle is 180 degrees. Let's name the first angle at vertex A. It is BAC plus the angle at vertex B is ABC plus the angle at vertex C is ACB equal to 180 degrees. So I named the three angles equal 180 degrees, and I write sum of angles in a triangle is 180 degrees. Now we replace. What do I mean by replace? The angles that I know their measures in numbers, I replace them by their numbers. Angle ABC, this angle, I replace it by 34 degrees, plus angle ACB is missing, so I keep it as it is, plus angle BAC is 120 degrees, so I replace it by 120 degrees. Now I add the numbers. 34 degrees plus 120 degrees is 154 degrees. Now to get the measure of angle ACB, I write angle ACB is equal always 180 degrees minus the one I have on the first side, minus 154 degrees. So angle ACB is equal to 26 degrees. Now inside the drawing, I write it is 26 degrees. This is a second example. Now I will solve a third example. Triangle ABC is right at A. Here in this sentence, I ask myself, again, what do we mean by right at A? Right at A means the angle at vertex A is 90 degrees. What is the angle at vertex A? It is BAC. So look, what do I write? Since triangle ABC is right at A, then angle BAC is equal to 90 degrees. If I don't write this, I will not know how to solve this question. Also, I have angle ABC is equal to 40 degrees. I have a missing angle ACB. So I know the angle at vertex B. I know the angle at vertex A. I have one missing angle at vertex C. So I add these three angles, give me 180 degrees. So ABC plus BAC plus ACB angle equal 180 degrees. This is the sum of angles in a triangle. Now let's replace. Angle ABC is 40 degrees, so I replace it by 40 degrees. Angle BAC is 90 degrees, so I replace it by 90 degrees. Angle ACB is missing, so I keep it as it is, equal 180 degrees. Now 40 degrees plus 90 degrees is 130 degrees. Now to get the missing angle ACB, always 180 degrees minus 130 degrees. So angle ACB will be 50 degrees. This is the missing angle. I got it. So these are three practicing exercises. Please solve them on draft again. Now, triangle MNP is isosceles of vertex M such that angle MNP equal 40 degrees. Okay, whenever I read isosceles of vertex M, so here in the name of the triangle, the special vertex is M. So this is the special vertex M. So because I'm talking about angles here, I should specify the equal angles. So if M is the special vertex, look what we do. I cross out M, which is the special vertex. I still have vertex N and vertex P. So the equal angles are at vertex N and at vertex P. So angle MNP will be equal to angle MPN. So this is what we write here. So we write, since triangle MNP is isosceles of vertex M, then angle MNP is equal to MPN. What is the measure of angle MNP? It's given 40 degrees. So what will be the measure of angle MPN? It's also 40 degrees. Please resolve these exercises because they are very important before I send you a worksheet to solve it. Now, I will talk about a very important part of our lesson, which is the particular lines in a triangle. In any triangle, I can draw many lines. In this lesson, I will teach you how we draw 4 important lines. The first line I will teach you in this session will be coming in the next slide. But before I start with the lines, in this lesson to draw, we need a protractor, we need a long ruler, and we need a set square. So to draw the following lines I'll talk about, we need these 3 rulers. Please prepare them with you. So you need a protractor, you need a long ruler, and you need a set square. Let me start with the first line. The first line is called a height. So again, a height. It has another name, or a perpendicular, or an altitude. So the first line I will talk about has 3 names: height, perpendicular, or altitude. It has a definition. You see this definition here. I want to underline the definition for you to be clear. This definition here, just wait a moment, please. This definition here, this following definition, the definition you see here, this definition should be memorized. This definition is very important and you should memorize it. What is the definition of the height, or the perpendicular, or the altitude? The height is a segment. So to draw a height, I will draw a segment from the vertex perpendicular to the opposite side. I want to tell you that we have a triangle ABC. How many vertices do we have? We have vertex A, vertex B, vertex C. How many sides do we have? We have side AB, we have side AC, we have side BC. If I'm asking you about side A, Which side is facing side A? It is side BC. If I'm asking about a vertex BC, which side is facing BC? It's AC. Vertex C, the side facing it is AB. So what does the definition say? To draw a height, I will draw a segment from the vertex perpendicular to the opposite side. To draw a height, we use the ruler, which is the set square. So if I wanted to draw the height from A, I should draw it to the opposite side BC. I bring the long ruler, I put it on BC, and I draw a height. I make the right angle sign. The height is called AM. So it starts from A and goes towards BC. Also, if I draw the height from B, it will go from B to side AC because AC is opposite to B. I put the set square on AC, passing through B, and I draw a height. After drawing the three heights from A, from B, and from C, as you can see, they intersect together. They meet here at a point, the blue point. This blue point where the three heights intersect, we call it an orthocenter. So we say in a triangle, the three heights are concurrent. This word is very important. What do we mean by concurrent? Concurrent means they intersect at a point called the orthocenter. Let's watch together this video. Okay. So this is how we draw the height. Please follow the steps you have seen in the video. Now the second line I'll talk about is called the median of a triangle. Also the definition of the median written in bold black, you should memorize it. The median is a segment from the vertex to the midpoint of the opposite side. So if I have a triangle ABC and I wanted to draw the median from A, which side is opposite to A? It is BC. So to draw the median, I should get the midpoint of the opposite side. To find the midpoint of a segment, we divide its measure by 2. So suppose the measure of BC is 6 centimeter. I divide 6 by 2, it is a 3. So I put M on the 3 centimeter. After putting M on the 3 centimeter, to draw the median, I just join. So to draw the median, I just join the midpoint with the opposite vertex. So AM is the median from A to BC. Also, we can draw the median from B to AC, we get the midpoint of AC using the long ruler. We measure AC and we divide the measure by 2 to get P. After getting P, we join P with B using the long ruler. Also, in a triangle, the three medians are concurrent. So after drawing the three medians in a triangle, they are concurrent. They intersect at a point. This blue point, which is the intersection of the three medians, we call it a centroid or a center of gravity. Let us watch a video so that you learn how to draw a median in a triangle. Okay, now the third line, we will draw it inside a triangle, is called the bisector. What is the definition of the bisector? Also, this definition should be memorized. The bisector is a line. So to draw a bisector, we will draw a line that divides an angle into two equal angles. So to draw the bisector, we draw it for the angle. To draw a bisector, we use a protractor. What do? We measure the angle, then we divide the measure by 2. Suppose I have angle CAB. To draw the bisector of angle A, I measure angle A. Suppose the measure of angle A is 80 degrees. So I divide 80 by 2, it is 40. I put the protractor in angle CAB and I assign on the 40 degrees, then I draw a line to get the bisector of angle BAC. After drawing the three bisectors in the triangle, also the three bisectors are concurrent. They intersect at the same point. The point of intersection of the three bisectors, we call it the in-center. Let's watch a video to know how to draw the bisector in a triangle. The final line I'll talk about that we can draw in a triangle is the perpendicular bisector. The perpendicular bisector, the definition is it's a line perpendicular to the side or to the segment at its midpoint. So to draw a perpendicular bisector, we use the long ruler and the set square. Suppose I have a triangle ABC and I wanted to draw the perpendicular bisector of AB. What we do is we measure AB using a long ruler. After measuring AB using a long ruler, we draw the perpendicular at the midpoint. So we get the midpoint of segment AB, we divide its measure by 2, and we draw a perpendicular using the set square. The three perpendicular bisectors in a triangle are concurrent. They intersect at the same point, and this point we call it the circumcenter. This point will be the midpoint. This point will be the center of a circle circumscribed or drawn around the triangle ABC. So after drawing the three perpendicular bisectors, these red lines are the perpendicular bisectors. They intersect at P. So P will be the center of the circle drawn around the triangle ABC. So if you get your compass, you put the needle of the compass at P and open it as B, then try to draw a circle. This circle will pass through the three vertices of the triangle. So circumscribed means around the triangle ABC. Now let's watch a video to show you how we draw a perpendicular bisector in a triangle. Okay, my dear students, so this was our lecture for this week. It is a lecture that has many things in it. It has many definitions in it. So please, I want you to take notes of this lesson on your math copybooks. Please study all the definitions, practice how we find the missing angle in a triangle. And until we meet on Zoom, please take care of yourselves. Thank you, my lovely students.